Today we will see about data structures. In that many topics are there in that data structure. Now we will see about Q. How Q is used in data structure and how it is implemented in C programming languages. We'll see. Now, Q in data structure. What do you mean with Q in data structure? It is used for storing and managing data in a specific order. It follows the principles of first in, first out, FIFO, where the first element added into the queue is the first one to be removed. Queues are commonly used in various algorithms and applications for their simplicity and efficiency in managing data flow. So these are the diagram for queue data structure where NQ, which means we are adding an element into the queue and we are deleting the element in the other end. Now, how the FIFO principle in queue is used? A queue is like a line waiting to purchase tickets where the first person in the line is the first person served. So first come, first served. Position of the entry in a queue ready to be served, that is the first entry that will be removed from the queue, is called the front of the queue, sometimes head of the queue. Similarly, in the position of the last entry in the queue, that is the one most recently added, that is called a rear or the tail of the queue. This is the diagram for there is an NQ and DQ, that is the function name. NQ is nothing but the adding the element into the queue, and DQ is nothing but the deleting from the queue. Where adding the element that is called the tail, that is the rear end of the queue, and deleting the element that is the front of the queue. What are the characteristics of queue? Queue can be handled multiple data. We can access both ends. They are fast and flexible. What are the basic operations on queue? Some of the basic operations for queue in data structure: NQ, DQ, peak or front, rear, is full, is empty, size. NQ is nothing but insertion of an element to the queue. DQ is nothing but removal of elements from the queue. Peak or front acquires the data element available at the front node of the queue without deleting it. Rear means this operation returns the element at the rear end without removing it. Is full, validates if the queue is full. Is empty, checks if the queue is empty. Size. This operation returns the size of the queue, that is total number of elements it contains. Again, the example shows that how the queue is worked and the NQ and the DQ is playing in this diagram. First, adding the element, before adding the element into the queue, the user must check whether queue is full or not. For that, NQ queue is full or not. Then only we have a space to adding the element into the queue. Otherwise, it will show that an error that the queue is overflow. And if the queue is not full, increment the rear pointer to the point to the next empty space. Add the data element to the queue location where the rear is pointed and return success. These are the example, and these are the example for which queue NQ is implemented using C language. These are the algorithms how to use it. And what is the time complexity and space complexity of the queue is big O of 1 and big O of n. Then what do you mean by DQ operation in queue? This operation removes and returns the element that is at the front end of the queue. The following steps are to be taken to perform the DQ operations. Check if the queue is empty first, and if the queue is empty, return the underflow error and exit. If the queue is not empty, access the data where the front is pointing. Increment the front pointer to point to the next available data element, and it returns success. These are the algorithms how to use a queue. Time complexity is big O of n, and space complexity is big O of n. And operation pre-front. So how the front operation is used in the queue. If the queue is empty, return the most minimum value, otherwise return the front value. And rear. If the queue is empty, return the most minimum value, otherwise return the rear value. And empty. Check if front value is equal to -1 or not. If yes, then return true means queue is empty. Otherwise, return false means queue is not empty. Full. Full means check if front value is equal to 0 or rear is equal to the capacity of the queue. If yes, then return true. Otherwise, return false. Size. Size is nothing but it returns the size of the queue, that is the total number of elements it contains. And these are the types of queue. And we are having simple queue or linear queue, priority queue, double-ended queue or DQ, and circle queue. So there are the four different types of queue which is used. So simple or linear queue is nothing but it insertion takes place from one end while the deletion occurs at the from the other end. Whereas the circular queue, in circular queue, all the nodes are represented as circular only. It is similar to the linear queue, except that the last element of the queue is connected to the first element. It is known as the ring buffer, as all the ends are connected to another one. These are the examples for circular queue. So how we can implement the circular queue or entire queue in C programming languages, which is showing for your reference. You can refer from this. So these are the how queue is used in data structure and what are the types and what are the functions used in queue data structure. Thank you. We will see the another next video in data structure. Thank you.